Lo que vemos es que a medida que aumenta el impulso de la ciencia y la tecnología, también aumenta la posibilidad de que esa ciencia y tecnología se conviertan en armas en una variedad de ámbitos. Antes, necesitaba estar extremadamente cerca de alguien para influir en él con un arma. Y ahora lo que vemos es que creamos tanto un potencial distal como un potencial mucho más capaz de afectarle de diferentes maneras, que van desde lo sublime hasta lo grave. Sabemos que esto existe. Hay dos tipos de armas: las que se denominan armas blandas y las que se denominan armas duras. Si ahora consideramos que las ciencias del cerebro son armas, una palabra real por cierto, podemos ver que, de hecho, las ciencias del cerebro son armas en ambas dimensiones: la posibilidad de que se conviertan en armas blandas y la posibilidad de que se conviertan en armas duras. En el primer sentido, y miso, si ahora hacemos la transición a formas más duras de militarización, estas son las áreas en las que realmente buscamos ejercer influencia física, no solo cognitiva, o disuasión. Estas son las formas más clásicas de militarización en las que realmente vemos cosas como armas, balas, bombas, etc. Pero ahora, cuando se limita al ámbito biológico, vemos sustancias químicas como fármacos y otros agentes químicos biológicos, como el uso de diversos microbios con bacterias, virus y toxinas. Y cada vez más dispositivos que hasta hace muy poco ni siquiera se consideraban armamentísticos. Y solo muy recientemente, con respecto a la última conferencia de revisión de la Convención Internacional sobre Toxinas y Armas Biológicas, el pasado diciembre, el grupo de Australia planteó la posibilidad de que ciertos dispositivos, concretamente la neurotecnología y los dispositivos híbridos de tipo cyborg, de los que hablaremos, deberían considerarse dentro de la escala más amplia de lo que podría ser un posible armamento biológico. Por lo tanto, lo que estamos viendo es que necesitamos ampliar la red a medida que aumentamos las capacidades, cada vez más sofisticadas. Son cosas como medicamentos, insectos, toxinas y dispositivos. Una vez más, medicamentos, insectos, toxinas y dispositivos. Todos y cada uno de ellos se están habilitando mediante formas de neurociencia y tecnología cada vez más sofisticadas, cada vez más avanzadas, e iterativamente más capaces y factibles. Hablaremos de cada una de ellas con cierto detalle, pero lo que podemos hacer con ellas no es solo desarrollar mejores medicamentos, sino medicamentos más específicos. Tuve la oportunidad y el placer de interactuar con algunos de los grupos de investigación aquí presentes esta mañana que trabajan en el área de la nanoarmacología. La idea de aprovechar la nanociencia para poder hacer que los fármacos sean más penetrables, más accesibles y más selectivos en su capacidad para hacer precisamente esto: dirigirse a sitios y redes cerebrales clave que han demostrado ser operativos y funcionales en ciertas formas de nuestros pensamientos, emociones y comportamientos. Además, para poder desarrollar nuevas formas de ciencia, también podemos desarrollar nuevas formas de neurotoxinas. Y dado que las neurotoxinas son en su mayor parte péptidos, se degradan con bastante rapidez. Pero aquí también, las formas de modificación genética, las formas de encapsulación y administración nanomicelar, pueden permitir que éstas se vuelvan disponibles y más potentes y viables para su uso en el ámbito de las armas. Y una vez más, ahora estamos exhibiendo un nuevo horizonte de posibilidades que es el espacio del dispositivo neurológico. Y desarrollar todos y cada uno de estos. Se los proporciono. No quiero entrar en detalles específicos sobre lo que hace cada uno de ellos porque no quiero provocarles pesadillas, y no me van a culpar si se despiertan sudando frío y gritando en mitad de la noche. Pero esto es lo que podemos hacer con estas cosas. Pensemos de nuevo en las drogas y los bichos. Si nos referimos a las drogas, nos referimos a lo que llamamos fármacos inclusivos. No son armas de destrucción masiva. Son armas de disrupción masiva. Pueden utilizarse para crear efectos específicos pero muy selectivos en las personas, de modo que puedan administrarse en dosis muy bajas, y aún así, producir un efecto de amplificación elevado, denominado potencial hormético, capaz de alterar las cogniciones, las emociones y los comportamientos. ¿Cómo se hace eso? Bueno, partículas. Ahora podemos utilizar la nanociencia para crear fármacos mucho mejores y llevarlos a donde tienen que ir en el cerebro. Puedo crear nanociencia y nanotecnología para poder escoltar ciertos fármacos a través de la barrera proliferante, que es la barrera hematoencefálica, y la barrera hematoencefálica del líquido cefalorraquídeo. De esta manera llevo estas cosas a donde tienen que ir, pero también puedo utilizar nanopartículas de forma muy indiscriminada. La idea aquí es que puedo obtener algo llamado material de alta agregación del SNC, que es esencialmente invisible a simple vista, e incluso para la mayoría de los escáneres, porque es tan pequeño que atraviesa selectivamente la mayoría de los niveles de porosidad del filtro. Luego se inhalan a través de la mucosa nasal o se absorben a través de la mucosa oral. Tienen una alta afinidad por el SNC. Se aglutinan en el cerebro o en los vasos y crean esencialmente lo que parece una diátesis hemorrágica. En otras palabras, una predisposición a la hemorragia o una predisposición a la formación de coágulos en el cerebro. Lo que he hecho es crear un agente de estimulación, y es muy difícil obtener atribución por hacerlo. Puedo usarlo en una variedad de niveles, desde el individuo hasta el grupo. Es altamente disruptivo. Y de hecho, esta es una de las cosas que han sido consideradas y examinadas en cierta medida por mis colegas de la OTAN y por aquellos que trabajan en el uso de las ciencias neurobiológicas para crear una disrupción poblacional. Estoy muy preocupado por el potencial de estos agentes nanoparticulados de ser agentes agregadores del SNC para causar disrupción neuronal, ya sea como disruptores hemorrágicos y vasculares, o como disruptores reales de la red neuronal porque interfieren con las propiedades de la red de varios nodos y sistemas neuronales dentro del cerebro. Luego llego al área. ¿Cuáles son los dispositivos? Bueno, los tengo aquí para ustedes. Tienen agentes inmovilizadores neurosensoriales, y hasta cierto punto, algunos de ellos ya se han utilizado. Cosas como estimuladores sensoriales de alto rendimiento que se pueden administrar desde vehículos no tripulados, drones, insectos o vehículos a gran escala como tanques, automóviles, etc. Estos son agentes de movilización sensorial que utilizan una alta energía de pulso electromagnético que también puede utilizar altos niveles de sonido, altos niveles de energía lumínica, y alteran la función sensorial neurológica. Ya se están utilizando, ahora se están desarrollando con mayor especificidad. La idea de los estimuladores de pulso intrarradiánicos lleva esto un paso más allá. Ahora la idea es utilizar pulsos electromagnéticos directos para poder alterar la agregación de redes neuronales. Se han realizado algunos estudios en animales que analizan la viabilidad de los pulsos electromagnéticos a varias distancias, para alterar esencialmente las propiedades de la red del cerebro y crear modelos de confusión. Por lo tanto, estos son disruptores tanto individuales como grupales. También tienes la idea de las tácticas de realidad alterada que se utilizan principalmente en la guerra irregular. Y aquí, una vez más, cuando entendemos la construcción de la forma en que operan las redes neuronales, operan mediante controladores clave e influyen en los nodos que interactúan con otras redes neuronales dentro del cerebro de forma electroquímica. Si podemos utilizar mecanismos transcraneales para poder interrumpir esto, lo que podemos hacer es crear una agregación de redes neuronales interrumpida y, literalmente, alterar el sentido del tiempo, el espacio y el lugar de las personas. Y ha habido una serie en algunos casos están buscando el uso a nanoescala de alto nivel, o al menos a microescala de bajo nivel, de varios electrodos que luego pueden registrar y quizás también administrar ciertos tipos de cargas útiles. Por lo tanto, la idea de volver ahora a estas dosis muy bajas de administración nanofarmacéutica de toxinas u otros productos químicos y utilizar esto como un vector controlado se convierte en una posibilidad real. Tenga en cuenta que esto no sea consideración, si así lo desea. Incluso podemos ir más allá. Uno de los desarrollos más recientes es que la materia nanoparticulada se puede estabilizar para su distribución. Si no sabe lo que es la materia nanoparticulada, es esa materia que existe en una escala de 1 por 10 Zeus 9.0, muy pequeña, más pequeña que una célula. Y podemos fabricar materiales que tienen propiedades discretas que se pueden controlar en virtud de la bioingeniería y su química física, para autoagregarse, y poder agregarse en particular áreas en función de su sensibilidad biológica androquímica. Pero ahora vamos un paso más allá. Hace tan solo unas semanas, se anunció que se podrían aerosolizar nanomateriales e ir un paso más allá. Puedo crear pequeñas unidades robóticas controlables a nanoescala, y que estas dos pueden aerosolizarse para crear un nanoenjambre de materiales biopenetrables que no se pueden ver, que pueden penetrar todos los filtros bioquímicos excepto los más robustos, que son capaces de integrarse a través de una variedad de membranas mucosas y donde sea, boca, nariz, oídos, ojos, pueden ser absorbidos por el sistema vascular para crear aglutinación. Pueden afectar al sistema vascular del cerebro o pueden difundirse directamente en el espacio cerebral, y esto se puede convertir en un arma, y se puede hacer a tal nivel que su presencia sea casi imposible de detectar. Y como tal, la atribución se vuelve extremadamente difícil de demostrar. ¿Cuánto de este material
is the use of very small scale sensors and transmitters that can be input to the brain non-surgically? And this is a current DARPA project, Defense Advanced Research Projects Agency project, that is referred to as N cubed, which refers to next generation non-invasive or minimally invasive neuromodulation. And it involves the use of neuroengineered sensors and transmitters that can be introduced to the brain space non-surgically, either via inhalation, injection, ingestion, absorption through a mucous membrane, migrated into the brain space utilizing some form of magnetic current due to the particular properties of these nanoengineered materials, and then utilizing this migrational pattern to form a relatively vast array of sensors and transmitters within the brain that allow real-time reading of information from the brain and writing of information to the brain remotely. Now, this is the one that gets, I think, really provocative, and I think in part of that provocativity, there's a particular contentiousness. If we consider that the functions of the brain writ large could be construed as mind, and axiomatically, this is a project that seeks to read information from the brain and write information into the living brain remotely in real time, then I don't care how you twist this. This represents some iteration, some construal of, quote, mind reading and mind control. Yes, indeed it does. Yes, we can. But can we infiltrate the brain space non-surgically, embed within the brain a vast array of nanomaterials that are capable of sensing and transmitting remotely in real time? And can we then use those aforementioned programs of machine learning and AI, utilizing various types of heterogeneous data, to then read from the brain and be able to interpret those electromagnetic signals of the brain in such a way as to reconstruct patterns of brain activity that can then be construed as viable cognitions, sensations, etc. And can you then be able to transmit information back into the brain in such a way that is going to be uptaken by the brain and then translated into some aspect of cognition, perhaps emotion, and perhaps also some execution of action behavior? So we're on that path. But perhaps a larger concern and a more immediate concern, what I would consider to be a clear and present concern, is the use of various technologies, inclusive, for example, certain types of drugs, certain types of microbes, certain types of directable energies that can affect individuals and groups of individuals in ways that they may not be aware at the time, to be able to induce effects that may be initially subtle, but are nonetheless profound in terms of altering their capabilities of thought, their clarity of thought, their ability to function, the types of thoughts they have, although we're not able to actually insert various types of thoughts, but certainly clarity of thought, vigilance, capability of thought, clear-mindedness, and there are a host of physiological functions, their balance, their coordination, their ability to do a job, their health. Yes, these things, those particular, what I would call targetable entities, represent a clear and present concern, and certainly within the scope of consideration, concern, consternation. And what we're pressing for at this point is the need for much more stringent oversight, regulation, guidance, and governance. So the, quote, elegance of nanomaterials is that because of their fairly small size, again, the scale is smaller than a cell, they're able to penetrate the physical and chemical barriers that block access from the bloodstream into the brain. This is called the blood-brain barrier, and there's also a second barrier that exists in the fluid that bathes the brain and the brain tissue called the blood-cerebrospinal fluid barrier. And these are both physical barriers in terms of the permeability of things coming out of the bloodstream into the brain space, but they're also chemical. They also have an ionic charge, and certain things need to be chaperoned across that barrier. But using nanomaterials, you're essentially getting, if you will, two capabilities in one. Number one, their small size makes some of these easily accessible across these barriers, but also you can imbue them with particular physical characteristics that allow them to then electrochemically go across these barriers because, if you will, they have the right credentials, so to speak. In other words, they have the ID card that allows them to transfer across the blood-brain and blood-cerebrospinal fluid barriers. So the, quote, beauty, the technical beauty of these nanomaterials is that they can be engineered in such a way that allow an increased penetration to the brain space. Now, could there be some capricious, concerning, and/or nefarious use of these? Could they, in fact, be inflicted upon an individual without this individual knowing? Well, yeah, actually they could. But let's back up. Remember that the sophistication and capability of the technology and science necessary to do these very, very specific tasks that are part of this directable research program that DARPA is undertaking, whereby we're able to get these materials into the body, migrate the materials into the brain space, establish these materials into a structural array that allows their functional capability to both sense what's going on in key areas and nodes and networks of the brain, and then transmit back into them. Well, this requires specificity. This requires dedication. This requires the adherence to specific protocols. But one of the things that my research group has been worried about is the use of nanomaterials more crudely. Nanomaterials that can be introduced very easily into a body by virtue of aerosolization, solubilization within various liquids, or impregnation onto various materials that are then uptaken into the oral mucosa, that are inhaled, that may be touched, that we know are going to migrate into the bloodstream, and we know are capable of migrating into the brain. And if they migrate into the bloodstream and into the brain, they can do two things. Number one, they can aggregate in the bloodstream of the brain, and they can induce problems with the vascular penetration or the vascular flow of the brain. In other words, they can cause what appears to be a stroke, and or they can actually disrupt the node and network electrical ionic communication of the brain, and they can serve as network disruptors that can then change cognitive capability, motoric capability, coordination, functionality in ways that are generally non-specific, but are no less disruptive. So the use of nanomaterials for rather crude, but certainly capable clandestine, if not covert weapons that are able to disrupt various aspects and domains of brain function, that's a real worry for us. You know, one of the issues when we're talking about the nanomaterials is you need to have proximity to the target. So these are what we sometimes call an in-close deployment. In other words, these are not weapons of, quote, mass destruction. You're not going to sort of perfuse these across a broad area, but rather they're more instruments of very specific disruption. You're looking to disrupt particular types of function or domains of function in a very selected key target, a high-value target or a group of individuals who, if you affect these individuals, the value of them as targeted individuals is highly disruptive and or can have ripple destructive effects on some aspect of their role, their function, or some other aspect of their individual capability, their group capability, and therefore their hierarchical functionality. But if you're looking at things like directable energies, whether it's sonic energy, infrasound, or ultrasound, or whether it's something further along the electromagnetic spectrum, for example, lasers and or rapidly pulsed microwaves, well, these things, number one, are directable. Number two, they can be used with relative clandestine, if not covert, capability.
And then we could be far more specific. We could put the drugs exactly where they've got to go. Easy enough, except for the fact that you're dealing with the brain. Last time I checked, that exists within a relatively hard structure called the skull. We don't want to be drilling holes in people's heads just to get drugs in there. We can. We can use something called microcannulation that deliver very, very low doses of drugs specifically where they've got to go. And the idea of using microcannula is a fairly old technique. I mean, literally decades old. Is one of the research techniques I used when I was a fledgling graduate student in the laboratory back in the early 1980s. And we can still do that. And there are a number of therapeutics that do directly deliver drugs into fairly selective regions of the brain at very low doses with high precision and high selectivity. But the brain is not just a chemical organ. Chemicals work within the brain to engage groups of nerve cells, both neurons and glia, that are aggregated in nodes that function in coordinated networks. And the dynamics of those networks literally shift based upon whatever cognitive, motoric, mnemonic, or conative task that individual is engaging. We've gone beyond thinking this place in the brain does that thing. This place in the brain, this node in the brain, is a collection, a clique of nerve cells that can dynamically interact in real time with a variety of other cliques of nerve cells that differ based upon what the task at hand may be. So by just affecting the chemistry of nerve cells, what we're really doing is we're limiting ourselves. We're only using one channel. We understand nerve cells operate electrochemically. So the idea of being able to utilize electromagnetic energy to be able to affect not just certain cells that have a particular chemistry, but organized cliques, nodes, and networks of cells in particular architectures and hierarchies in discrete ways, well, that's where the technologies connect. And neurotechnologies can be used in tandem with drugs to lower the dose of drugs to potentiate force multiply drugs, and vice versa. Drugs can also be used together with a variety of phyto and nutraceuticals to augment and force multiply the effect of a variety of cutting-edge technologies. And as you've noted, those technologies range from peripheral stimulation of the peripheral nervous system and or the vagus nerve engaging a centralized tract that engages a lot of different brain nodes and networks to be able to control not only autonomic function, but emotional tone, parasympathetic and sympathetic activity, and overall tone of both default networks and various utility networks in the brain. We can use various forms of transcranial modulation, and I prefer to call them transcranial rather than non-invasive. And the reason for that, I think, is beyond semantic. I think it's important conceptually. You're putting energy into the brain. And so what you're doing is you're taking an energetic, and the energetic field is invasive to the brain space. So those arguments that say, well, are they really non-invasive? They're non-surgically invasive. They don't involve a physical invasive implanted substrate, but you are invading the brain space energetically, either with electrical current or magnetic current, to affect the function of various structures of nodes and networks of the brain. So the idea of using transcranial stimulation, whether it's electrical or magnetic or some combination of both, in various arrays that can be put on and put off wearables, donables and doffables, well, there's great ease that goes along with that, relative facility that goes along with that. But those things still tend to be a little more generalized. Characteristically, the best of those systems will penetrate only into the deeper levels of the cortical mantle. They don't go down to deeper levels, the subcortical levels of the brain. And yeah, it's true. You can back propagate some of those effects so that by affecting the superficial layers of the brain, you sort of get a downstream effect in deeper levels, but you're doing that somewhat indirectly. If you really want to sharp shot the brain, now you're talking about implantables. And those implantables began decades ago with deep brain stimulating technology that has now come through a number of successive iterations to be a very, very specific, very precise, and very, very granular form of being able to stimulate, modulate a variety of discrete brain areas, not just with single crude electrodes, but with electrode fields, vast arrays of electrodes. Probably one of the most advanced systems, something referred to as the Omni device, that was pioneered through DARPA projects, the SubNets project. The system was based on neurotechnologies for emerging therapeutics that were the Brain Edition. And that particular device, co-developed with MIT, Lawrence Livermore Laboratories, Medtronics, and SAPI, was a multi-electrode device that was both open loop and closed loop capable, that was utilizing multipolar sensing and transmitting electrodes that allowed exceedingly precise, exceedingly specific capability to modulate a number of different brain nodes and networks at different areas in the brain, again, utilizing either a closed loop self-controlled system, an open and closed loop programmable system, or an externally controllable system. Well, as we're seeing is an increased capability of these technologies to be used not only singularly, but in combination. And so these sort of hybrid systems of transcranial and indwelling devices that can be coupled with lower doses of drugs. What we're understanding about now utilizing various very, very low levels of drugs that can induce what's called a hormetic effect. In other words, low dose of drug that can then be amplified through the use of a variety of magnetic or electrical modulation to then get force multiplication effects within the target areas of the brain. But let's see, just based upon what I just spent the past 7 minutes telling, what I'm really telling you is that the capability of the science and technology now allows tremendous capacity to be able to assess the brain, access the brain, and affect the brain. And if we consider the brain to be the substrate through which cognition, emotion, behaviors, memories, identification, intentionality arise, and we consider those latter characteristics to be colloquially the mind, then we are standing in the atrium of the capability to be able to scan the brain to essentially read what's going on in the mind and being able to affect the brain, modulate brain function to be able to control the mind. Just saying it that way certainly at least opens Pandora's jar so that the gremlins come out with the goodies. And the very implication of, quote, brain scanning for mind reading and brain affecting for mind control certainly at that point called the wolves out of the den. And there's a host of ethical, legal, and social issues that are inherent to that and that are contingent to that in terms of how it's being used, for what it's being used, who's using it, to what ends, and what we'll do with the knowledge that comes out of it.